Hi everybody, welcome. I'll be taking you step by step through how our tantos are assembled. As you can see, one of them is already completely assembled and the other one is in all its separate components laid out on the table, with one exception, and that is that inside of this grip there is a ball retention cylinder, and I have one here in my hands, as you can see, which is pressed into the component itself, so it's really hard for me to take it out, and therefore I left it in. I know Jörg and I promised that we would put a video on Instagram, but Instagram only allows me to create a video of 1 minute maximum, and well, we're already at 48 seconds here, and it's physically impossible for me to put this together in 1 minute. Believe me, I've tried, but especially with having to explain things to you guys as well, it just doesn't make sense. So I decided to create a little bit longer video, upload it to my YouTube channel, and it's either likely that we are linking directly from Jörg's video to my YouTube channel, or you were brought here via my Instagram account, in which case I am very thankful that you have followed 2 links to get here. Okay, having said that, so these are all the components. We already explained in the longer video that the lock design in this specific setup is very similar to the Beukerslijk, and actually very similar to all those out of the front knives which need 2 hands to operate. And I'll be showing you this by first assembling the blade portion. So the blade, this one's 3D printed, it's just polymer, but it's the same shape as we intend it to be in the actual metal. As you can see, there's a chamber here. We have this small component, which is the unlocking ramp, actually, and we'll get back to that in a minute. And then we have, let's see if it wants to focus. We have the lock return spring, and we have a standardized threaded bolt with a large head, which is the actual lock itself. And it's assembled very easily. First we drop the spring over the, see if it wants to focus, over the lock portion. We push it into the cavity inside the blade, ensuring that the ramp is facing forward, like so. And then we push it into the cavity a little bit, which then allows us to thread in the bolt, just by hand in this case, because the cavity inside the blade actually functions now as a wrench in and of itself, so it's very easy to assemble like this. Okay, so it's in there now. Now you can see that it's on like so. And if we press the ramp, obviously it pushes the lock down. Okay, so that's assembled. Then we have the portion of the grip, one of the outside scales, which is actually responsible for the locking. And this is a 2-step or a 2-part assembly, actually. And the rationale behind this is that this is something we can easily mill, so this is very production friendly. And as soon as you do something like this, it's very hard to mill a negative cavity, so it makes more sense to do this in 2 parts. And now if we take the blade, you can see that the hole size corresponds with the lock. So if I push it in, it can't move because it's interfacing with this material here. But as soon as I push the ramp, I can now slide it backwards. So that's now in place. Okay, we're going to put that aside for a little bit. Then we have the center portion of the grip, and this is actually the portion responsible for separating the blade of the grip inside the handle itself from the opposing blade coming in, which is trying to be or which will be sheathed. And as you can see, the big benefit of this setup, this lock setup, is that the distance between the 2 blades is very, very small. We really optimized it for that purpose. because that also means that each blade in its respective grip is as close to the center as possible. Okay, so having said that, you can also see that inside here, and actually take one out to show it. So these are just hexagonal standoffs. They're M3 at the moment. And the reason I use these inside here is because it's hard to thread a 3D printed part. And this cavity inside here is hexagonal. So you push these in and now you have metal threads which you can easily replace if there's an issue. Obviously in a production run, this would be a metal part in and of itself and it would have its own threads. Okay. So what we can now already do is place this component. And I need to be careful that the hexagonal inserts do not drop out. Place it on top of the, turn it around, place it on top here. And now you can see that the ramp also slides through this slot here. So the lock on one side is guiding it, but the ramp is also sort of guided through the center section of the grip. Okay, so now we're going to turn this around, place it flat on the table, and now we have three screws. There's a long one for the back, and there's two shorter ones that go into the guard. I'll just be threading them in. Bear with me here. It's a bit awkward doing this from this position, but we're getting there. Yep, that's one. And when you're threading screws in and out often, bolts, it's always a good idea to first go against the thread direction, so loosey, lefty-loosey, and until you hear it click, and then you know that the threads are engaging. That's the best way I found to ensure that you're not ever cross-threading anything. It's just a small tip there. Okay, and this one, a bit fiddly like this. All right, okay, those are in. Good. Okay, now we can turn it around, and now we're almost done actually. So this grip scale is really a simple part. There's nothing to it. The only thing it has is the ball retention cylinder in there, and the reason why we placed it in this location with this specific lock design is because here we actually have enough flesh for the depth of the small component that goes inside. Anywhere else and it would protrude from the grip and we would have to change the design. We're not sure yet if the production version will have the same type of retention because this one's metal, so I'm thinking it makes more sense to have the ball itself be a polymer so that it doesn't scratch the blade. Well, we'll see. Anyway, I can literally now just throw this on top, do the same thing with the screws, and we should be good to go once that's done. Yep, that one's in. And then again, the trick with the threads. Backwards first. Yep, there you go. All right, last one. And then once it's assembled, we should be able to pull out the blade, and then you will hear the lock snap into its forward position. Okay, so now it's all together, right? And we know now the blade is fully backwards, and we actually created this little cavity here so that it's really maximizing the amount of overlap we have inside the grip. And if I now pull it out At the end you'll hear it click, and now it's locked. Can't go back in. Very solid. And now if we take the opposing blade and we slide them into each other, they lock.